the world today, right, is therefore defined by poverty, with the need for clean energy, by different forms of pollution. You already said that earlier. Climate change, food supply not being consistent across the world, and of course, the pandemic. Right? The pandemic is not going to be the last diseases, the last disease we are going to face. The pandemic is probably going to be the first of the many. Okay? So we hope that we will have solutions to face future pandemics that are coming along. So what science education must do is to increase our understanding of humanity, to increase accessibility to technology, more technology and more know-how, how to use the technology. We need to promote responsible lifestyle. Now, promoting responsible lifestyle is not simply us telling. They need to have knowledge. They need to have knowledge, they need to have experience before they know how to be responsible. And of course, to make help citizens make good decisions and to generate solutions to the grand challenges. To help citizens make informed decisions will help you to solve the problem of the making themselves very fair, right? The bad chemicals, because they're making informed decisions. Now, so right now we talk about the challenges of science learning and STEM learning. As it stands right now, science education or science teaching and learning, we focus a lot on content understanding. We only focus on content understanding. How students solve equation, how do you do addition, subtraction. It is monodisciplinary. One discipline. Right now, we give students problems, but the problems that we give the students are simple, convergent problem, right? Simple, convergent, meaning that in a math worksheet, you can give them 5 problems, 10 problems. The student only need to spend 1 hour or 2 hours to solve the problem. So the problems are simple problems with one definite answer. We present science as unproblematic. Right? We present science as unproblematic. There's only one correct answer. There's no problem about it. But that's actually not true. And we teach our students in a very teacher-directed and curriculum-directed manner. The teacher decides what you can learn. You have no say. You have no choice. Agree? So my challenge to all of us as educators, be it in Singapore, in Cambodia, or any other parts of the world is this. Can we slowly, not the time next week you go home, you start to change, no. Can we slowly consider and move from here to here? Where we don't just look at content. Content is important, but we want to look at content in a context. Content in a context. In a social context. Right? Just now, when I was trying to get you to think about this, I was trying to present the importance of content. But this content, if it's not within a context, would not be very meaningful. Okay, later remind me to tell you why. Okay, so can we present content within a social context? Just like the insulin that we did, right? The insulin activity. I can teach you all about hormones. Insulin, hormones, diabetes, blood sugar level. That is content. But you learn it, but you don't know how to apply it. Right? So what we are trying to do with the insulin activity is to present it content in a context of Amma trying to regulate her blood sugar level. So there we present it as interdisciplinary, more than one discipline. Where you need math knowledge, you need science knowledge, you need to put in some form of design. Can we present problems as complex, persistent, and extended real-world problems, rather than simply focusing on simple, convergent problem solving? And of course, we must let the students appreciate the fact that science science is a human construct. Science is not produced by robots. Scientific knowledge is produced by humans. Can humans be wrong? Yes. So can science be wrong?
Yes.
Yes, of course. Because many of our students think that because it's science, it's always correct. That's not true. Okay? They must understand it's produced by humans. And to have greater student engagement and ownership in the learning process. Yes.
Professor, I'm not clear about discipline. No more discipline, interdiscipline.
This one? Mono means you only teach it as science, as math, and English. Mono, one discipline.
One subject.
Yes, one. Interdisciplinary, more than one.
More than one.
More than one.
Multidisciplinary.
Okay, which is the next slide. Wait, this one. Okay, this is the slide. I think a friend asked me, what's it? How do you make sense of integration? So these are different ways of looking at integration. We can look at disciplinary. Disciplinary here is just one discipline. Mono, yes, very good. Mono, one discipline. All right? So here is what we do right now. We teach students, or students learn the concepts and skills separately in different disciplines. So the math teacher goes into the math class. The math teacher teaches only math. The bio teacher goes into the biology class and teaches only biology. And so on and so forth. One discipline. So students learn math, students learn biology. That's what we do now. And that's what many education systems do. Because it's the easiest way to do it. I'm the expert, the student learn. Multidisciplinary is another way. Multi means more than one. Many, right? Multi. So in multidisciplinary, we're looking at students learn the concepts, students still learn concepts and skills separately in each discipline. Same as this one, right? But what is the change? But in reference to a common theme. In reference to a common theme. So, for example, if the theme is sustainability, this week, let's say, in school, this week the theme is sustainability. The math teacher will teach calculation of carbon emission. The biology teaches sustainability farming. The physics teacher teaches sustainability in terms of energy production. How to reduce work done, etc. with reference to sustainability. The English teacher teaches ideas related, how do you write articles related to sustainability? Am I making sense? So everybody for that week, all the subjects will talk about sustainability. That is multidisciplinary with reference to a common theme. But every subject, because the theme will require knowledge from different subjects. So that's called multidisciplinary. So what your students will learn would be sustainability, but the different aspects of sustainability.
More than one subject.
My colleague, Dr. Gina, was just telling me about her son in the international school. She says, I'm not sure if he's learning anything. I said, why? He said, because the whole term, 10 weeks, the theme is on rivers, body of water, rivers. And so he learned in geography, different rivers around the world. The Han River in Korea, the Mekong River. He learned about all the rivers location in the world for geography. In chemistry, he learned about how to test water quality in rivers. In biology, he learned about all the living things you can find in different types of rivers. Different rivers in different parts of the world. In history, he learns about the historical ideas of the historical civilization around the different rivers. In English, he learned about how to write poem related to rivers. So that is multidisciplinary learning. It's based on a theme, based on an idea. So the theme is rivers, or the theme can be interactions. Or the Singapore primary science and lower secondary science curriculum is thematic. We teach around a theme, a specific theme. So at the end of the term, like Dr. Gina's son, he will become an expert with rivers, right? He will have all the various ideas from the different disciplines on rivers. Okay, so that is multidisciplinary. Now what about interdisciplinary? If you look at this, the ideas here are the same. Students learn concepts and skills. Same, right? Yeah? But here says, students learn concepts and skills from 2 or more disciplines that are tightly linked so as to deepen the knowledge and skills. So here, in interdiscipline, means that the 2 disciplines have very close resemblance. They are tightly linked together. So 2 or more disciplines, they learn the concepts and skills that are tightly to deepen the knowledge. So for example, an example of an interdisciplinary that requires two knowledge to solve would be if you go back to the idea of the helping the blind people see. All right, back to the idea of helping the blind people see. The 2 disciplines that are really required to help blind people see is biology and engineering. Because you need to engineer certain products based on the biology to help them see better. So these 2 help you understand how light is reflected, how light can be rechanneled, redirected to help the blind people see. That's interdisciplinary. As long as you have 2 or more. Can it be 3 disciplines? Yes. Can it be 4 disciplines? Yes. That is interdisciplinary. What about transdisciplinary? Which is all, remember, it looks like this is the highest level of integration. In transdisciplinary, if you read this, it says, by understanding real-world problems or projects, students apply. Here, learn. Here, learn. Here, learn. Here, got learn. Apply. Yeah. So what this tells us is, in transdisciplinary, it's different. Notice that this, and this don't have real world problems. Don't have, right? They didn't say must be real world problems. But here, real world problems. And what does it mean if you want students to engage with transdisciplinary problem solving? They must have learned the knowledge.
The content.
Right? Because if they don't have the knowledge,
they don't know
how to apply. They don't know, right? They don't know anything, they can't apply. They need to know it first. So in transdisciplinary, this is the highest level. So I put here, like for example, an example here is like designing a delivery system to deliver water to remote villages in the mountain. This is a real world problem that we observe in Thailand. Right? Thailand has the mountainous areas. I'm sure you have that in Cambodia, where the water supply is not like the city. So the students were asked to design a solution to deliver clean water supply to mountainous areas. Now the students cannot work on this if they don't understand the concept of gradient. Correct? If they don't understand the concept of rate of water flow. If they don't understand the concept of clean water. These will be the 3 key concepts they need to know. So the teacher must teach them first. So the math teacher, so what you can do is to engage in multidisciplinary learning. right? To get the math teacher, biology teacher, the science teacher, the design teacher to talk about design of water delivery system, to talk about the geography of mountains, talk about these around the common theme of helping remote villages. Talk about that, and then you can get them to solve this particular problem. Make sense?
Yes.
Okay? So this is the different ways of integration. When we look at the blind people, when we did the insulin, when we did the right, these are all here. Why? Because I assume you all have already learned the various concepts. But if it's your student coming to you, don't assume they have learned. You need to put in lessons to teach them first, to accumulate to them transdisciplinary problem solving. Okay?
Yeah.
Make sense? I'm just trying to do a summary before we do the next activity. My summary is very long. Okay. So with this idea in mind, like I mentioned, you did the insulin delivery, right? We did this as the first activity. Okay. This one I will do on next Tuesday. How do you map it into the stem cortex? All right, this one we will do. Okay, so this is what you did. Okay, then today we want to do sustainable farming. Now, earlier before lunch, we also talked about there are two types of sustainable farming. You can have urban farming in the urban cities like Singapore, or you can consider urban farming, a vertical farming where it's a small plot of land, you build upwards. So when you are actually teaching your student, you want to ask them questions like, where does the food come from? I think with your Cambodian students, they are probably cleverer than the Singapore student. If you ask a Singaporean student, where does the food come from? Yes, the supermarket. Where does the chicken? Some of our children have never seen a real chicken. So if you ask them draw a chicken, they will draw KFC for you. No, really. I'm sure your Cambodian students are not like that, right? Some in the city.
Yeah.
So we need to ask them, where does food come from? Because we don't assume they know. Okay? Then you of course get them to talk about it. So you realize where food comes from. They come from the farm, right? In Singapore, they get imported from other countries, but ultimately it's from the farm. Do countries import all their food from other countries? No. Yes. Sometimes we import the part of the product, right? Sometimes we grow our own food. So countries, you import some food, but not all. I think I was talking to one of your friends, and then they say you import a lot of chocolates in your country because you don't grow cocoa. Correct? We import all our chocolates. Right? Same thing. So, but when countries have floods, climate change causes flood, hurricanes, drought, food production is affected. Yeah? So food supply can go down, or diseases, right? So today we want you to solve a problem. In limited land area, where there is the context is in a country, we don't say Singapore, but in a context where the context is a country where there's limited land area and the country relies on heavy food imports. So the problem would be need to be self-sustaining and climate change, and that the problem is also climate change affects the crop yield. Okay? So the scenario is this. You are given 6 hectares of land to produce 120 tons of kailan in a year using traditional farming methods. Now, what is kailan? Do you know? Do you know what kailan is? It's a vegetable. It's a yummy vegetable. It's a Chinese leafy vegetable. It's like a leafy, you know what's broccoli, right? It's like a leafy version of broccoli. Okay? So kailan is a why will we give this example? This example because kailan is a high value crop. High value crop means expensive. So farmers like to grow high value crops because they can sell for more money. So farmers will not make a choice to grow low value crops. Things like
Waste the time.
what is a cheap vegetable? Bean sprout. Taugeh. Bean sprout? Mung bean? The green beans?
Bean sprouts.
Bean sprouts. You know what bean sprouts are?
Yes.
Yeah. Bean sprouts are not high
Like
value
a dog.
crops. Okay, bean sprouts are cheap.
นี่มันซื้อชิมนานมาก
So if you grow a lot of bean sprout as compared to growing a little bit of kailan, so there's a difference. Okay, one of my colleagues who is a professor of food security, he says farmers also need to learn or people need to learn how to increase the value of their food. I said, what do you mean? He said, for example, if you sell vegetable, you can sell one plate of vegetable for say $8. But if you take that vegetable and you put it into flour and you fry it, it's called tempura. That one plate of vegetable, because you fried it, you can sell it for $20. So the fact that you put it into flour and egg and fry it increase the value. Okay, so he said that's but the ingredient is not expensive, but the value increases by a lot. Okay?
So
your job is to usually we will need 120 6 hectares to grow 120. But now because of land use, you now only have 2 hectares. Instead of 6, you now have 2 hectares, which is reduced by from 6 to 2, reduced 3 times. Yeah, but your output must be the same. Okay, the land instead of 6, you now only have 1/3 of it, but you still need to produce same amount of kailan vegetable. So your challenge is how to do it. So your task is this. Sketch out, I'll give you paper, a new farming system that allows the production of the same amount of kailan in the limited land space. After that, you build a model of your sketch. Hey, wait, you need to sketch it first before you build. There is a reason for that. I will ask you later. I will tell you later. You need to sketch first. Sketch means draw. Draw it first. Draw it on paper, 2D first. Then you build a 3D. Okay, I repeat. Don't just go and jump into room.
Oh.
Don't just jump into building without I hate this. Like lock me out. Okay, wait. Wait. Okay.
Style right.
So sketch first. I repeat, sketch first, draw first, then build. If I see anybody build without drawing, I'm going to scold you. Okay, so the paper is here. I have got paper here. Okay, plan how you want to do the farm. now only with 2 hectares. Okay, sketch first. And then the materials, I think you just do 2 groups because I don't think I have enough, unless you want to share the scissors and all that. Okay, you can do either 2 groups or 3 groups. All the materials that you can use, I have some sticks. I have some different types of straws. I have 3 different types of straws, all of different diameter. Right? These are the paper straw. This is the plastic straw. This is the bubble tea straw. Hey, do you all drink bubble tea? Yes. Do you all love bubble tea?
Yeah.
How come it's like international? It's yeah. Okay. There are also ice cream stick, aluminum foil. There are some little plastic containers that you might need, and there are whatever this is net that you can use. Boards, glue gun over there. Hey, somebody took away my glue gun socket. Okay, you need to plug it in to use the glue gun. And there's twine and everything on the table. Okay? So, wait. You have to build your structure here. This is 2 hectares of land. 2 hectares. This is 2 hectares. So your structure must be here. Got it? What must you do? Very good. Draw first, then build.
Design.
There's a reason for that. Later you will. Okay? Now do it.